locking plug. Okay, locking plug is in the stored position, and plug and filter internal. This is the electrical connector stored as a mirror image. Okay, just remember the components in one pack are installed as a mirror image panel. Okay, that is the one they said we can open it from in the ECS bay. We can open it that panel. And hello everyone, welcome to K-Vision Engineering YouTube channel. All right, so after a long time, actually I have some problems happens last few months, couple of months. Something sad because my mother was passed away, so I have to do so many things. Sorry because I took this lesson after a long time. Okay, all right, so no worries. Now I again refresh, and I'm going to make the videos for you guys because I saw so many comments come to me. All right, so I don't want to talk a lot. Hope you guys watch my previous videos and got a good knowledge about aircraft maintenance, especially the modules and the 80 chapters. And now today I'm going to take the part 3 Boeing 777 80 chapter 21 air conditioning part 3. All right, so let's go to the video. All right, so today I'm going to teach Boeing 777 level 3 type 80 chapter 21 air conditioning system under that part 3. So I did part 1 and part 2 before. So today I'm going to do part 3 pack cooling and mixed manifold temperature control. All right, so under this the contents are I'm going to discuss about introductions and the pack cooling and mixed manifold temperature control. Under this one I'm going to talk about the RAMIA and the dual heat exchanger and the economy cooling check valve, air cycle machine and the condenser, reheater and the water collector and the spray nozzles, low limit and turbine bypass valves and the economy cooling valves. So condition air check valves, pack cooling temperature sensors, manifold temperature sensors, RAMIA inlet doors and actuator, fan inlet diffuser housing and check valve, and control part 2 and the last one the packs. Okay, so these lessons I'm sure it will be longer, so if you're interested about this, just watch this video until the end, and I'm sure you will get a good knowledge. All right, so let's go to the first one, the introduction. All right, so the purpose. What is the purpose? The pack cooling and mixed manifold temperature control system controls the temperature of the air coming out of the pack. Okay, temperature of the air coming out of the packs. Okay, so it makes sure enough cool air is supplied to the flight decks and the mixed manifold. Okay, just remember the purpose of this one is the pack cooling and mixed manifold temperature control system control what? The temperature of the air coming out of the packs. Okay, so that is the one, make sure that air supply to the flight deck, cockpit and also the mixed manifold. So the air conditioning AC packs is used to cool the hot bleed air from the flow control system, remove moisture from the air and provide comfortable air to the aircraft. Okay, all right, so the pack performs 3 main functions. Okay, I will discuss how it look like the packs. Okay, so the pack performs 3 main functions. What are they? First one, the cooling the air using the RAMIA and the heat exchangers, and the second one, cooling the air using the air cycle machine, and the last one, removing water and moisture from the air. Okay, just remember, first one, cooling the air using the RAMIA and the heat exchangers, and the cooling the air using the air cycle machines, and removing water from the moisture from the air. All right, so normally air flows through the pack in the following sequence. Okay, normally this is the sequence I can see. Okay, this is called the packs. Okay, you can see this is the air cycle machines and the primary secondary heat exchangers. Okay, all right, so let's see. Initially the airflow come to the primary heat exchanger and the air cycle machine compressor, and then go to the secondary heat exchanger, and then go to the reheater and the condenser cores, and then the water collector, reheater, again reheater, and then air cycle machine turbine 1, and then the condenser, and then come to the air cycle machine turbine 2 and conditioning air check valve, and last mixed manifold. Okay, all right. So that is the airflow through the pack. This is like a summary. See the primary heat exchanger, then the airflow goes to the air cycle machine compressor, and after that the airflow goes to the secondary heat exchanger, and after secondary exchanger is go to a reheater and condenser, and then after reheat and condenser is go to the water collector, and the water collector to the reheater, and then the reheater again go to the air cycle machine turbine one, and then the again condenser, and then air cycle machine turbine 2 and check valve and the manifold. Just remember, this is the flow of the air flow. I mean, this is the flow, how the airflow if enter to the primary exchanger and how is go to the mixed manifold. These are the components is the airflow is passed through. All right. Okay, so this is the pack. Okay, you can see this is the pack cooling and mixed manifold temperature control introduction. Okay, this is some okay, you can see this is the mixed manifold. From this one they will distribute to the cabin, cockpit, cargo. Okay, so you can see the air from the left pack for control valve. Okay, you can see it's got the primary go to the primary come to the air cycle machine. Okay, you can just check, just stop this video, you can take a screenshot and then go to the this one and just check how is the flow is going on. Okay, all right. So after leaving the pack, the conditioning air enter the mix manifold where it mix when conditioning cabin air. The mixed air is then distributed to the passenger cabin. Okay, so the flight deck receive air directly from the left pack. Remember, the flight deck receive air directly from the left pack. Okay, they have two packs, right and left, and the ram air is used to cool the heat exchangers and keep compressor outlet temperature within limits. It's also help control the pack outlet temperature, and the right pack operates in the same way as the left pack. Okay, left pack and the right pack are same. Okay, the operation is very same. All right. Okay, you just go through this diagram. Okay. All right. So now let's go to the pack and cooling and mix manifold temperature control. All right. So the most of the pack cooling and mix manifold temperature control components are located in the environmental control system bay, ECS bay. Okay, in the Boeing 777. Okay, these are the words. So you can see most pack cooling and mixed manifold temperature control components are located in where? In the ECS bay. ECS means environmental control system. So 4 mixed manifold temperature sensors are installed in the aft section of the forward cargo compartment. Okay, when you go inside to the forward cargo compartment in 3x7, you can see very big, it's like a spider. Okay, so that is the mixed manifold temperature mixed manifold. Okay, inside in this mixed manifold they are installing 4 temperature sensors. Okay, so each environmental control system bay, left and right, contains one AC pack. Okay, one pack is there, and one conditioning air check valve, and also ram air system components. Okay, so let's see components in each pack. Every pack has some components. Okay, each pack okay, uh, so components in each pack. Okay, each pack contains let's say economic cooling valve and water collector, low limit valve, and the water overflow and water spray nozzles and temperature sensors. They have 10 locations. Okay, and the economic cooling check valve and the dual heat exchanger, fan bypass check valve, and the fan inlet and diffuser housing, and air cycle machine, and second stage turbine bypass valve, and also condenser and reheat. These are the components in each pack. Okay, all right. So yeah, let's go the left and right packs. They have two packs, right? Left and right. So the left and right packs are most identical. Okay, left and right packs are most identical. The only difference is 5 connecting ducts between the components. Okay, left and right packs are almost same, identical, and the only difference is 5 connecting ducts between the components. Right, the component is one pack are installed as a mirror image. Okay, just remember the components in one pack are installed as a mirror image of the other pack, and the airflow is also a mirror image. Okay, airflow and the components on I mean the two difference pack. Let's see, the components on one pack are installed as a mirror image of other pack, and also the airflow also a mirror image. So the difference duct arrangement ensure that the dual heat exchanger inlet is always at the top and the outlet is always at the bottom. Okay, just remember the difference duct arrangement ensure that the dual heat exchanger inlet is always at the top. Okay, dual heat exchanger inlet is always at the top and the outlet is always at the bottom. Okay, just remember. All right. Okay, you can see this one. Okay, this is the left environmental control system bay. Okay, ECS bay. Let us see environmental control system bay. Okay, see, you can see this is the second stage turbine bypass valve. This is second stage turbine bypass valve, and this is low limit valve. Okay, we will discuss about this one. This is low limit valve, and this is the water collector, and you can see this is the economic cooling valve. Okay, economic cooling valve, and you can see this is the yeah, this one is the turbine 2, this one is the turbine 1. Okay, here is the fan. Okay, this is you can see this one is all is air cycle machine. Okay, this is called the full component is called air cycle machine. All right. Okay. All right. So yeah, so now let's go to the yeah. Okay, so now let's go to the pack cooling and mixed manifold temperature under this one, RAM. All right. So all RAM system components for the left and right air conditioning packs are located in the underwing fuselage area. Okay, all the RAM system components of for the left and the right air conditioning packs are located in the underwing fuselage area. Okay, so each pack has the following RAM air components. Every pack have these are the RAM air components have. Okay, so let's see the RAM air inlet door. They have two sections. Each pack have the following RAM components. Okay, let's see. The first one is RAM inlet door. They have two sections. Okay, what is the purpose? RAM inlet door. This one does the control the amount of RAM enter into the system. And the next one, RAM inlet door actuator. They have a RAM inlet door actuator. So what is the purpose? Open and closes the RAM inlet door. And the next one, RAM inlet duct. You can see a big duct, that is RAM inlet duct. What is the purpose? Carries RAM to the pack. And the RAM inlet duct clean out panel. Okay, RAM inlet duct clean out panel. What is the purpose? Provide access for inspection and cleaning. And next one, fan bypass check valve allows airflow when required and prevent reverse flow. And next one, the fan inlet and diffuser housing. Okay, fan inlet and diffuser housing guides air into the fan section. What is the purpose of inlet and diffuser housing? The purpose is guides air into the fan section. And the next one, fan section of the air cycle machine. Fan section of the air cycle machine. What is the purpose? Moves RAM air through the heat exchangers. Moves RAM air through the heat exchangers, especially during low speed ground operation. And the last one, RAM exhaust housing. RAM exhaust housing allows RAM to exit after it has cooled the pack. Okay, these are the RAM components inside the packs. Okay, so let's see the summary. The RAM air system brings outside air into the pack. Okay, RAM air system brings outside air into the packs to cool the heat exchangers. Okay, the air enter through the RAM air inlet door, passes through the duct and then go to the fan section, cool the packs and then exit through the RAM air exhaust housing. All right. Okay. All right, so you can see the pathway. Okay, this is the Ramya inlet door, and this one have a actuator. Okay, this one have a actuator, and then the air is coming from here, and it goes to here and circulate from the air cycle machine, everything, and then go out from the Ramya exhaust housing. All right, okay, and this is situated in the under wing fuselage area. Okay, all right, so you can see this is the pack. Okay. All right. Now let's go to the Dual heat exchangers. Dual heat exchangers is also under pack cooling and mixed manifold temperature control. Dual heat exchange. So what is the purpose? The dual heat exchangers remove heat from, okay, dual heat exchanger, secondary heat exchanger and primary heat exchanger, okay. So what is the purpose of these two? These are, the dual heat exchangers remove heat from hot air coming from the pneumatic bleed air system and air compressed by the air cycle machine, okay. All right. Okay, so what is the purpose? The dual heat exchanger removes heat from hot air coming from the pneumatic bleed air system and also air compressed by the air cycle machine. Okay, so this helps cool the air before it continues through the pack. Okay, so let's go to the physical description. Physical, okay, how is it look like? So the dual heat exchangers contain a primary heat exchanger and also the secondary heat exchanger. All right, it has inlets and outlets. It has inlets and outlets for pneumatic system air and also ram air. Okay, for the packs, I mean, for the dual exchanges, heat exchanges, they have ram air is coming, ram air also come, and also the pneumatic system is come from the engine, okay, bleed system, it's also comes, okay. That is the way they cool the air, okay. All right, so the dual heat exchangers is removed and installed as a one complete unit, okay. When you remove dual heat exchangers, we have to completely remove the both of them. We can remove, we can separate it for the cleaning purposes, but normally we remove it as a complete set. Okay, so the weight of this dual heat exchangers is 194, approximately 194 labs. It means 88 kilograms. Okay. All right, so let's go the left and right pack installation. So the heat exchangers in the left and right packs are identical. Okay. However, they are installed as a mirror image of each other. Remember, they are identical, almost same, but we install as a mirror image of each other. And the airflow also as a mirror image. So the pneumatic system air enters to the top and exit from the bottom. Remember, the pneumatic system air for the dual heat exchanger, secondary, primary, the pneumatic system enters from the top and exit from the bottom. And ram air always flow from outboard to inboard. Remember, okay, this is tricky maybe, okay, we can make a question, right? So let's see, pneumatic air system, I mean neutral system air always come from top and exit from bottom, but the ram air always from outboard to inboard, outboard to inboard. Okay, so as a maintenance note, you can see a panel located outboard of each ECS access door provides access to the heat exchanger clean out panels. So high pressure air or water can be used to remove dirt and debris from the heat exchanger cores. Okay, so as a summary, the dual heat exchanger cool the hot bleed air and the air cycle compressed air cycle machine compressed air. So it contain a primary and secondary heat exchanger. Ram air, I mean use ram air for cooling and is installed as one unit in the pack. So the left and right units are the same but mounted as a mirror image. Okay. All right. So yeah, you can see this one, right? So this is a dual heat exchanger. Okay, dual heat exchanger. This is the secondary inlet, primary inlet, secondary outlet, primary outlet. Okay, and you can see this is the heat exchanger core, and the ram air always come from outboard and exit from the inboard. Okay, ram air is coming like here and then goes from here. Okay, this is the fan bypass outlet. This is look like the heat exchangers. It's very big. Okay. All right. So this is the clean out panel. Okay. That is the one they said we can open it from in the ECS bay. We can open it, that panel, and we can clean out. Okay. So this is the Ramya inlet duct. Okay. This is the access panel to clean out panel reference. Okay. And this is the air cycle machine. Okay. So this is show it as a left pack. Okay, now let's go to the okay, economy cooling check valve. Economy cooling check valve. All right. Okay. Just wait a moment. Okay, economy cooling check valve. We're going to talk about economy cooling check valve under pack cooling and mixed manifold temperature control. All right. So what is the purpose of this one? The economy cooling check valve allows air to bypass the air cycle machine compressor. Okay, the economy cooling check valve allows air to bypass the air cycle machine compressor when the pack is starting to operate and the air cycle machine has failed. Okay, what is the purpose of this economy cooling check valve? It allows to bypass the air cycle machine compressor only the pack is starting. I mean, pack is start to operate, and also when the air cycle machine has failed. Okay, in these two scenarios, the economy cooling check valve allows to pass the bypass the air cycle machine compressor. So when the valve is open, okay, when the valve is open, air flows directly from primary heat exchanger to secondary heat exchanger without passing from the air cycle machine compressor. Okay, in this situation, when the valve open, you mean the economy cooling check valve is open, then air flows directly from primary heat exchanger to secondary heat exchanger without passing from the air cycle machine compressor. So let's see the physical description. Okay, all right, physical description. The economy cooling check valve contains two spring load flappers. Okay, two spring load flappers, and that open automatically when needed and close when normal airflow through the air cycle machine compressor is restored. Okay, it is a two spring loaded flappers that automatically open when needed. So as a summary, the economy cooling check valves provides an alternate airflow pathway. All right. So the economy cooling check valves provide an alternate airflow path around the air cycle machine compressor during pack startup or air cycle machine failure. So it uses two spring-loaded flappers and allows air to flow directly from the primary heat exchanger to the secondary heat exchanger. All right, so yeah, this is the economic cooling check valve. This is look like, so this one is like two spring loaded. Okay, you can see the primary heat exchanger, secondary heat exchanger. In this situation, what happened if in the startup when the pack is starting, and also when the air cycle machine is failed, in this situation the economic check valve, what will do, economic cooling check valve, they bypass the air which is goes to the air cycle machine compressor. All right, okay, yeah, now let's go to the air cycle machine. Air cycle machine is under pack cooling and mixed manifold temperature control. All right, so the purpose, the air cycle machine compresses air in the compressor stage and cools air in the turbine stages. Okay, what is the, it's also same like the engine. Okay, same like the engine. What is the purpose of the air cycle machine? This one compresses air in the compressor stage. In the compressor stage, they compress the air and cools air in the turbine stage. Okay, about the physical description, the air cycle machine consists of one compressor stage, two turbine stage, and one ram air fan. Okay, air cycle machine consists of one compressor stage and two turbine stage. Okay, one compressor stage and two turbine stage, and also one ram air fan. This look like engine. So all three components are connected to the same shaft. Okay, all three components are in engine they have N1, N2 like this, but this one very basic one. So this one, all three components are connected to the same shaft. The shaft is supported by air bearings. That is important. Okay, the shaft is supported by how? Through the air bearings, so which keep it in position while it rotates. Okay, so the functional description, when we talk about the functional description, the compressor receive air from the primary heat exchanger. Okay, for the compressor, the air cycle machine inside, we have one compressor and two turbine stages and one ram air fan. Okay, so the when we talk about the function, okay, for the compressor, the air is received from the primary heat exchange. Okay, and the compress the air increase its pressure and send to the compressed air to the other pack components. And next one, the turbine. Each turbine receive air from different location in the packs. As the air passes through the turbine, it expand. Okay, when the air passes through the turbine, what happens is expand, not compress. Okay, it expand and it's become colder. So the energy released during expansion turn the air cycle machine shaft. Okay, remember, when the air is go to the turbine, what happened, the air is expanded. At this time the air is cool, and when the energy is released during the expansion of the air, this one used to turn the air cycle machine shaft. Okay, all right. So the ram air fan, what is the ram air fan? The connected to the same shaft as the compressor and the turbine, move outside ambient, I mean outside air through the ram air ducts. Okay, move outside air through the ram air ducts and mainly helps cooling when the aircraft is on the ground and natural ram air is low. All right. Okay, so as a maintenance note, you can see there is a direction arrow and placards on the air cycle machine. Okay, in the air cycle machine, they have a directions arrow and the placard showing the correct direction. Okay, showing the correct direction to rotate the shaft before a torque check. Okay, there is a directions arrow and placards on the air cycle machine showing the correct directions to rotate the shaft before torque check. So important, never rotate the air cycle machine in the wrong direction. Okay, don't rotate the air cycle machine into other direction, I mean wrong direction. So doing so can damage the air cycle machines. The placard also shows the maximum allowable torque. Okay, in the placard it shows the maximum allowable torque. So always before do this one, use the placard to see the placards. Okay, what is the torque value and which directions you need to rotate. So as a summary, the air cycle machine is the heart of air conditioning pack. So it has one compressor, two turbine and ram air fan on common shaft. Okay, it's on the air bearings, and the compressor increases its air pressure, compressor increases air pressure, turbine cool the air and expansion, and then the fan helps move cooling air through the pack, especially on the ground. All right. Okay, you can see this is the air cycle machine. Okay, you can see the air cycle machine, turbine outlet 1, turbine, and turbine 2 bypass inlet valve. Okay, you can go through this. This is the air cycle, typical air cycle machine. Okay, its location is here. Okay, yeah, you can see this is the turbine section. They have two turbine. Okay, and compressor have only one stage, turbine have two stage, and this is the ram air fan. Okay, all connected to the one shaft and is under the air bearings. Okay, all right. So now let's go to the condenser and the reheater under pack cooling and mixed manifold temperature control. All right. So the condenser or reheater has two main functions. Okay, what are the one? First one is cool the air and the heat the air. Okay, condenser and the reheater. What is the two functions? Cool the air and heat the air. So the cool the air before it enter the water collector, before the air enter to the water collector, allowing moisture to condense into the water so it can be removed. And the next one, the heats the air after the water collector, adding energy to air before it enter the air cycle machine turbine. So this helps the turbine operate efficiently. So the condenser reheater contains a condenser core and a reheater core. Remember, a condenser or the reheater contains what? A condenser core and also reheater core. So these heat exchangers cores are installed inside the housing through which packed air flows. The weight is approximately 32 kilograms. Okay. So let's see the functional description. Condensing function. Let's see what is the function of, the condensing function. So air from the secondary heat exchanger, air coming from the secondary. Okay, now let's see, it's go to the primary heat exchanger, then it's go to the air cycle machine compressor, then again go to the secondary heat exchanger. So now secondary heat exchanger is the reheater condenser. Okay, so the air from the secondary heat exchanger enter the condenser or reheater, and this air flows over the condenser and reheater cores. This cores remove heat from the air, causing its temperature to decrease. As the air cools, moisture condenses as a water. The air then flows to the water collector. After reheater condenser, then it's go to the water collector. Because why? When it is cool, it's make it as a water, right? Water collector where the water is removed. All right. So now next one is the reheating function. After the water collector, the air enter the reheater section. Okay, initially the air comes from secondary heat exchanger, is come to the condenser. Okay, And then the reheater section, the air absorb heat from the reheater core. Air absorb heat from the reheater core. This increase the air temperature and energy before it enters the air cycle machine turbine. Now let's see the condenser function. Air leaving turbine 1 enter the condenser section. This cold air absorb heat from the warm air following over the condenser core. So the warm air then leave the condenser. Okay, this is the functional description. All right. So why is it important? Why the reheater condenser is important? So removes moisture from the air. This one used to remove the moisture from the air and prevent water from entering downstream components. Okay, and increase turbine efficiency by reheating the air before expansion. Okay, increase turbine efficiency by reheating the air before expansion and improves overall pack cooling performance. All right, so let's see the maintenance note. The condenser, reheater and the water collectors are removed and installed together as one assembly. Okay, so the condenser, reheater and the water collector, three components, condenser, reheater and the water collector are removed and installed together as a one assembly. This keeps the weight balance and using the hoist adapter. As a summary, the condenser reheater cools the air to remove moisture and then reheat the air before it enters the air cycle machine turbine. So this helps remove water from the air and improve the turbine performance. Okay. All right. So you can see this is the location. Okay. This is the location reheater and the condenser reheater. Okay. Yeah, it's look like this. Okay, condenser reheater. This is the components is look like this. You can see this is the reheater. Okay, and this is the condenser. Okay, and when you about this graph, you can see the condenser reheater here. All right, and it's coming from the secondary heat exchanger and it's go to the economic cooling valve. Okay, this is the water collector here. Okay, all right, you can go through it. Now let's go to the water collector and the spray nozzle. Water collector and the spray nozzle. Okay. So the water collector removes water from the pad. It's normal. Okay. Water collector, what is the purpose? Is removes water from the pads. So the spray nozzle sprays collected water into the ram air inlet duct. Okay. Remember inside the water collector, it's remove the water from the moisture and it's keep it. And what the spray nozzle do, this sprays the water into the ram air inlet duct. For what? To cool the air. Okay, so the water overflows allows excess water to drain directly into the ram air inlet duct if water collector become full. Remember, there is a water overflow. Okay, water collector, spray nozzle, and also they have a water overflow. What is the purpose? Water overflow allows excess water to drain directly into the ram air inlet duct if the water collector become full. So let's see the water collector now. Okay, water collector, the function. Let's see I mean, how is water collector? So has no moving parts. Water collector doesn't have any moving parts. Contain internal vanes that the air moves in circular swirling motion. And the spray nozzle has no moving parts. Consists of pintle, nozzle, housing, water drain line connector. The location is the water collector and the spray nozzles are installed outboard of the condenser reheater in each ECS bay. All right. Okay, so let's go to the functional description. Air enter the water collector. Initially, air enter the water collector, and the air is forced into the circular motion by the internal vanes. And the spinning action separate the condensed water from the air. Because of the spinning action, it separates the water from the air. And the collected water is sent by air pressure to the spray nozzle, and the spray nozzle sprays the water into the incoming ram air near the secondary heat exchanger. The water cools the ram air and improves the heat removal capability of the secondary heat exchanger. So much water. Okay, and yeah, if too much water collects, the overflow allows the excess water to drain directly into the ram air inlet duct. Okay, all right, you can see this is the location. Okay, this is the water collector, and the spray nozzles also there, overflow also there. Okay, you can see this is the yeah, this is the drain connection left back. Okay, this is the overflow line, this is the overflow area, and this is the overflow line connection also. and the drain, this is the drain line connection. Okay, so this is the water collector. Okay, and you can see this is the spray nozzle. Okay, water drain line connected here, and this is the spray. This is the pintle nozzle housing. Okay, all right. Yeah, let's go to the next one. Now let's go to the low level and yeah, low limit and turbine bypass valve. Low limit and turbine bypass valve. Okay, let's go to the low limit valve. LLV, low limit valve. The low limit valve controls the amount of air that bypasses the first stage turbine of the air cycle machine. Okay, remember the low limit valve control the amount of air. Okay, bypasses the first stage turbine of the air cycle machine. So the cabin temperature controller, CTC, cabin temperature controller uses this valve, I mean low limit valve, to keep the turbine outlet temperature above 34 Fahrenheit, I mean above 1 Celsius. This prevents water is in the air from freezing. Okay, so let's go to the second stage turbine bypass valve. Turbine bypass valve. The second stage turbine bypass valve control the amount of air that bypasses the second stage turbine. So the CTC, it means the cabin temperature controller, uses this valve to control the pack outlet temperature. Okay, what second stage turbine bypass valve it uses to control the pack outlet temperature, and the low limit valve is used to control for what? To keep the turbine outlet temperature above 34 Fahrenheit. It means above 1 Celsius. Okay, so together with the ram air doors, these valves helps control pack temperature. Okay, to control pack temperature, what are the main valves helping? Low limit valve and also second stage turbine bypass valve. Okay, all right, so let's go to the physical description. The low limit valve and the turbine bypass valves are identical valves and consist of valve body, rotating disc, electrical actuator, position indicator, manual open and close knob is there, and also electrical connector. So the valve disc rotates to control airflow. Okay, the valve disc, as a valve disc, is rotates to control the airflow. The actuator motor operates on 115 volt AC voltage and can rotate the valve in both directions, open and close. The rotary variable differential transformer send valve position information. Okay, rotary variable different transformer, it send valve position informations to the cabin temperature controller. The visual position indicator on the top of the actuator shows the valve position. All right, so let's go to the functional description. The cabin temperature controller controls both valve. Okay, low limit valve and the turbine bypass valve, both controlled by the cabin temperature control. So the cabin temperature controller send an open and close commands to these valves, and the actuator motor moves the valve disc, and the rotary variable differential transformer send valve position feedbacks to the cabin temperature controller, and the cabin temperature controller uses this feedback for valve control and position indication. All right, so that is the function. Okay, functional description. And let's go to the maintenance note. The valve can be opened or closed manually using the manual knob. The valve can be open or closed manually using the manual knob. There's a manual knob. So before manual operation, disconnect the electrical motor. Remember, the valve can be open or closed by using the manual knob. Okay, and the before manual operation, we must disconnect the. Hello. Okay, so maintenance note, the valve can be open or closed manually using manual lock. Before manual operation, disconnect the electrical motor. And if power is still connected, the valve will automatically move back to the position commanded by the cabin temperature control. So as a summary, low limit valve prevents turbine outlet temperature from dropping below 34 Fahrenheit, it means 1 Celsius, to avoid ice formation. And the turbine bypass valve control pack outlet temperature. Control pack outlet temperature by bypassing the air around the second stage turbine. Okay, turbine bypass valve, what is the function? Control pack outlet temperature by bypassing air around the second stage turbine, and the both valves are controlled by the cabin temperature controller and work together with the ram air doors to regulate pack temperature. That is the summary. All right. All right. Yeah. Okay, so you can see these are the valves here. Okay, you can see this is the low limit and second stage turbine by the identical valves. Okay, you can see the valve body is here, and here is a disc. Okay, this one we can rotate manually. Okay, this is the manual open and shut knob here. Okay, this is the electric actuator. Okay, when we open and or close this valve, we can use this manual knob, but when we use this one, we need to disconnect this one. Okay, we need to disconnect the electrical connection. Okay, all right. This is the position indicator. Okay, this one is the position indicator, the valve position indicator. All right, so you can see this is the secondary stage bypass valve here. Okay, low limit valve is here. This is the secondary stage turbine bypass valve. Okay, you can see these are the two positions locations. Okay, all right. So now let's go to the economy cooling valve. Economy cooling valve. So the economy cooling valve allows air to bypass. Economy cooling valve allows air to bypass air cycle machine turbine 1. Okay. Economy cooling valve allows air to bypass air cycle machine turbine 1. Water separator components, condenser, reheater, and the water collector. The valve opens when the pack operates in. Okay. I mean, this valve opens when the pack operates in economy cooling mode and standby cooling mode. Okay. In which time, I mean, economy cooling valve is operated in which situations? When economy cooling mode and standby cooling mode, when the pack is operating under economy cooling mode and the standby cooling mode. So this provides an alternate airflow path through the pack. So let's go to the physical descriptions. The economy cooling valve consists of a locking crank position indicator and the pneumatic actuator and the locking plug, plug and filter, solenoid, electrical connector, valve body, valve disc. The valve disc is moved by pneumatic actuator to open or close the valves. Okay. So let's go to the functional description. The economy cooling valve is electrically controlled, pneumatically actuated. Okay, remember the function of this economy cooling valve. It is electrically controlled, pneumatically actuated. Okay, so in the normal operations, the valve is spring loaded to close. In normal operation, the valve is spring loaded to close. When the solenoid is not energized, no electrical power. In normal operation, the valve is spring loaded to close when the solenoid is not energized. Okay, not energized. When the in normal operation, what happened? The spring loaded to close, and when the solenoid is not energized, it means no electrical power. Control pressure enter the actuator and open the valve. Okay, when the solenoid is not energized, remember, control pressure enter the actuator and open the valve. When the solenoid is energized, the control pressure is released. From the actuator and the valve closes. Okay. This valve is spring loaded to close. Okay. When the solenoid is energized, what happened? Control pressure enter the actuator and open the valve. When the solenoid is energized, what happened? Control pressure is released from the actuator and the valve closed. Okay, just remember. Now the summary, the economy cooling valve open to let air bypass turbine 1 and water separator system during economy cooling and standby cooling modes. Okay, this one works when the packs operate under economy cooling mode and the standby cooling mode. Okay, it is electrically controlled and pneumatically actuated. pneumatically operated, and can be manually locked, closed using the locking plug. Okay, we can manually close also. Okay, we can manually close this one. At that time it cannot work. Okay, manually locked, close using the locking plug. So that is the summary of economic cooling valve. Let's see how it look like. So this is the economic cooling valve. You can see this is the locking crank position indicator over here. You can see this is the pneumatic actuator, and this is the locking plug. Okay, locking plug is in the stored position, and plug and filter internal. This is the electrical connector. Okay, electrical connector, and here is the solenoid. Okay, here is the valve body. This is a DC, this is spring loaded. Okay, the location is here. Okay, location is here. All right. And now let's go to the condition air check valve. Condition air check valve. All right. So the condition air check valve prevent a loss of cabin pressure. Okay. A condition air check valve prevents a loss of cabin pressure if an air conditioning duct fails or leaks in the ECS bay. All right. So what happened in the conditioning air check valve? What the purpose is prevents a loss of cabin pressure. Okay, if the air conditioning ducts fails or leaks happen in the ECS bay, what happens? Suddenly pressure can be leak. What the conditioning air check valve, it prevents the loss of cabin pressure. Okay, so this helps maintain cabin pressurization and protect the aircraft from excessive pressure loss. All right, so the conditioned air check valve is a single flapper type valve. Remember, the conditioning air check valve is a single flapper type valve. So the flapper opens when conditioning air flows normally and closes automatically if reverse airflow occurs. Remember, the flapper opens when conditioning airflow normally and closes automatically if reverse airflow occurs. All right. So the locations, you can see the conditioning air check valve is located at the forward end of the ECS bay. All right. The conditioning air check valve is located where? At the forward end of the ECS bay, attached to the forward cargo compartment pressure bulkhead. Okay, this is in the forward end of the ECS bay and attached to the forward cargo compartment pressure bulkhead. Okay, access to the valve is through the ECS low pressure connection doors. All right, so the summary, the conditioning air check valve is a single flapper. Okay, the conditioning air check valve is a single flapper valve that prevents cabin pressure loss if an air conditioning duct fails in the ECS bay. So it's located at the forward end of the ECS bay on the forward cargo compartment pressure bulkhead. Okay, it's also very important. All right, so you can see this is located here, attached here. Say this is the forward, this is the flapper one. Okay, flapper, and this is flapper type 1, and this is the valve body. All right, this is the ECS low pressure connection access here. All right. Okay, so now let's go to the pack cooling temperature sensors. Pack cooling temperature sensors. All right. So, yeah, the pack cooling temperature sensors monitor air temperature at different locations. The pack cooling temperature sensors monitors air temperature at different locations in the air conditioning pack. These temperature signals are used by, okay, remember the pack cooling temperature sensors monitors air temperature at different locations in the air conditioning pack. These temperature signals are used by what? Cabin temperature controller and air supply cabin pressure controller. Remember, okay? So the cabin temperature controller for control, monitoring, built-in test and indications, okay? And the air supply cabin pressure controller for pack and pressurization functions, okay? These sensors used by those items for what? Let's see, the cabin temperature control they use for control, monitor, built-in test and indications, and also the air supply cabin pressure controller used for the pack and pressurization control. So the primary heat exchanger inlet temperature sensors provide temperature data for the flow control system. Okay, all right, so the temperature sensor locations, let's see, the pack has temperature sensors at the following points. The primary heat exchanger outlet temperature sensor, the primary heat exchange outlet temperature sensor, and the compressor discharge temperature sensor 1, and compressor discharge temperature sensor 2, and compressor discharge temperature sensor, and the secondary heat exchange outlet temperature sensor, condenser inlet temperature sensor, condenser inlet temperature sensor 2. So secondary turbine inlet temperature sensor, pack discharge temperature sensor, pack discharge temperature sensor for the air supply cabin pressure control. Let's see the physical description. Each sensor has an electrical connector. Every sensor have electrical connector and a threaded housing. So the sensor are installed in the threaded bosses on the air conditioning ducts. So these are two sensor types. They have two types of sensors: resistant temperature sensor RTD type and the thermistor sensors. So the resistant temperature sensors, it means RDT type, primary heat exchange outlet temperature sensor, and the compressor discharge temperature sensors, compressor discharge temperature sensors for the air supply cabin temperature control, and this is for the cabin temperature control. And the secondary heat exchange outlet temperature sensor, these are RDT type. RDT means resistance temperature sensor type. And the thermistor sensors, they use for condenser inlet temperature sensor and the secondary turbine inlet temperature sensor, and also pack discharge temperature sensor. All right. So the locations, all pack cooling temperature sensors are installed in the air ducts within the ECS bay. Okay. So interchangeability, when we talk about interchangeability, the following sensors can be exchanged with each other. Okay. Let's see the RTT, resistant temperature detector sensors. Primary heat exchanger outlet temperature sensor, they can exchange, and the compressor discharge temperature sensor CTS with the CTS number 2, cabin temperature control number 2, and the compressor discharge temperature sensor for this one, and the secondary heat exchanger outlet temperature sensor, and the primary heat exchanger inlet temperature sensor. Thermistor sensors, condenser inlet temperature sensor number 2, and the secondary turbine inlet temperature sensor. The pack discharge sensors, pack discharge temperature sensor for the CTC, and the pack discharge temperature sensor for the SCPC. As a summary, pack cooling temperature sensors measures air temperature at different points in the pack. Okay, pack cooling temperature sensors measures air temperature at different points in the pack. So the cabin temperature controller and the other one, what is the name? Air supply cabin pressure controller. Okay, cabin temperature controller and the air supply cabin pressure controller uses these informations to control pack operation, monitor system performance, and provide indications. The sensors are installed in the ECS ducting, and some sensor types are interchangeable. Okay. All right, so you can see the sensor locations around the ECS bay. You can check. You can see. I will tell you example. This one, primary heat exchange outlet temperature sensor here. Okay, and this is a threaded type. Okay, and this is the compressor discharge temperature sensor for the cabin temperature controller. Okay, you can see this is the pack discharge temperature sensor. They have two. Okay, like this. Now let's go to the manifold temperature sensors. Manifold temperature sensors. Alright, so the mixed manifold temperature sensors monitor the temperature of the air in the mixed manifold. Okay, mixed manifold temperature sensors monitor the temperature of the air in the mixed manifold. There are 4 mixed manifold outlet temperature sensors. Remember, there are 4 mixed manifold outlet temperature sensors installed in the system. The temperature information is sent to the cabin temperature controller for monitoring and temperature control. So the sensors are single element thermistor sensors. Remember, manifold temperature sensors are single element thermistor sensors. Okay, the sensors are single element thermistor sensors. Each sensor has a sensing element, thermistor, a sensing element is there, and the external hex fitting for wrench installation or removal, and the threaded for installing into the mixed manifold. So the locations, the sensors are installed on the top of the mixed manifold. Okay, the locations of these sensors are, they are installed on the top of the manifold, mixed manifold. To access them, open the flexible neoprene liner and go to the aft end of the forward cargo compartment and access the mixed manifold area. Alright, so about the interchangeability, the 4 mixed manifold temperature sensors are interchangeable. Remember, these 4 mixed manifold temperature sensors are interchangeable with each other. They are also interchangeable with the cabin zone duct temperature sensors. Remember, these sensors can be interchanged with the cabin zone duct temperature sensors. All right, so as a summary, the mixed manifold temperature sensors measures the temperature of the air in the mixed manifold. And these are four thermistor type. These are the thermistor type sensors installed on the top of the mixed manifold. Their temperature signals are used by the cabin temperature. These temperature signals are used by the cabin temperature controller to control and monitor the air conditioning system. They are interchangeable with each other and with cabin zone duct temperature sensors. As a quick note, the thermistor, a temperature sensor whose electrical resistance changes with the temperature. The controller uses this change in the resistance to determine their air temperature. All right. These are the four temperature sensors. Okay, you can see this is located in the top of the mixed manifold. Okay, this is the mixed manifold. You can see this mixed manifold when you enter from the forward cargo, and it is in the rear of the forward cargo. You need to remove the panel. Nice. Okay, to see this one. This is very huge area. All right, so this is the manifold temperature sensors look like this. Okay. All right. Let's go to the ram air inlet door and actuator. Ram air inlet door and actuator. Alright, so the ram air inlet door controls the amount of ram air that flows through the dual heat exchanger. Remember, the ram air inlet door controls the amount of ram air that flows through the dual heat exchanger. By controlling the ram air flows, it helps to control heat exchanger cooling, pack cooling efficiency, pack outlet temperature. So the ram air inlet door works together with the other pack components to maintain the required air temperature. Alright, so the ram air inlet door is made up of two sections. Okay, forward section and the aft section. So what in the forward section permanently attached to the ram air inlet. Remember the ram air inlet door is made out of two sections, forward section and the aft section. Forward section permanently attached to the ram air inlet and mounted with the hinge. And the aft section attached to the forward section by a free hinge supported by the rollers at the rear. So the door is operated by an actuator. The door is operated by an actuator that turn a torque tube which moves the aft section of the door. So the location is the ram air inlet doors are located on the bottom of the aircraft. Ram air inlet doors are located in the bottom of the aircraft and forward of the ECS bay doors. Alright, the functional description, the cabin temperature controller control the ram air inlet doors. Cabin temperature controller is the one who control the ram air inlet doors, I told you before. So the cabin temperature controller send an open or close command. The actuator motor moves the door. The rotary variable differential transducer transformer in the actuator send door position feedbacks to the cabin temperature control. So the cabin temperature control uses this feedback to control the door position and pack temperature. Okay, so in the ground operation, normally the ram air inlet doors are open when the aircraft is on the ground. Remember, ram air inlet doors are open when the aircraft in the ground. If necessary, maintenance personnel can use the maintenance access terminal MAT. Maintenance access terminal special function to close the ram air door. Okay. All right, so this is the location. Okay, you can see this is the location. This is the actuator here. Okay, and this is it's like a free hinge. Okay, and this is the track, and okay, you can see the actuator here. Actually, this is the ram air inlet door and actuator. Okay, this one open, close. Normally in the ground is open. Okay, all right. So now let's go to the fan inlet diffuser housing and check valve. Fan inlet diffuser housing and check valve. Alright, fan inlet diffuser housing. Fan inlet diffuser housing. The fan inlet diffuser housing connects the dual heat exchanger, the air cycle machine fan and ram air exhaust ducts. Okay, the fan inlet diffuser housing connects the dual heat exchanger, air cycle machine fan and ram air exhaust duct. So it guides and separates the airflow going to and from the air cycle fan. Fan bypass check valve. The fan bypass check valve allows air to bypass the air cycle machine fan when ram air flows in high. This helps reduce unnecessary fan load and improves airflow efficiency. All right. Okay. So let's go to the physical description. Fan inlet diffuser housing, a metal housing assembly, and has flexible connection at ramia inlet and fan bypass duct. Contains an internal structure that separates airflow, right? The flow to the air cycle fan, machine fan, and flow away from the air cycle machine fan. And it includes a support strap that attach to the aircraft structure to support the housing when components are removed. Okay, so the fan bypass check valve, a flapper type valve. Okay, fan bypass check valve is a flapper type valve, open or close automatically based on airflow conditions. Okay, so functional description, at low ram airflow. At low ram airflow, air is directed through the air cycle machine fan to assist cooling. At high ram airflow, the fan bypass check valve open and allows air to bypass the air cycle machine fan. Remember, at low ram airflow, air is directed through the air cycle machine fan to assist cooling. At high ram airflow, the fan bypass check valve opens and allows air to bypass the air cycle machine fan. So this prevents excessive airflow resistance and improves system efficiency. So as a maintenance note, this support strap must be installed when installing the fan inlet diffuser housing, and the strap supports the housing when the air cycle machine or dual heat exchanger is removed. Okay, as a summary, the fan inlet diffuser housing connects the dual heat exchanger, air cycle machine fan, and the ram air exhaust ducts and control the airflow path. The fan bypass check valve allows air to bypass the air cycle machine fan during the ram air conditions to improve efficiency and reduce load on the fan. Okay, you can see this is the fan bypass check valve. Okay, it is located over here. Okay, this is the dual heat exchangers. This is the air cycle machine fan here. Okay, this is the ram air flow. Okay, this is to the to ram air exhaust. Okay, this is located over here. All right, now let's go to the control. The cabin temperature controls control the air conditioning packs to maintain comfortable cabin and cockpit temperature. So they mainly control the mix manifold. Okay, cabin temperature controller controls the mix manifold temperature, and to calculate the value called IMMT, it is integrated mix manifold temperature error. Okay, control the mix manifold temperature to calculate a value called integrated mix manifold temperature error reference. Okay, to keep both pack outlet temperatures within about 10 Fahrenheit, means 5.5 Celsius of each other. All right, so mix manifold target temperature, IMMTE, mix manifold target temperature. All right, so the IMMTE reference is the target temperature for the mix manifold air. So it is calculated based on cooling needs, heating needs, and cabin zone temperature, cabin zone demands. Okay, so the right cabin temperature controller usually calculates IMMTE, and the left cabin temperature control follows the right CTC. Okay, remember always right one is the one usually calculates the integrated mix manifold temperature error. Okay, and the left one always follows the right cabin temperature controller. If the right cabin temperature controller fails, then the left cabin temperature controller takes over. Okay, so what this cabin temperature controller directly controls? The cabin temperature controller adjusts these components to control the temperature. What are the components? Ram air door actuators, second stage turbine bypass valve, and low limit valve. Okay, what are the CTC directly controls? The cabin temperature control adjusts ram air door actuators, secondary stage turbine bypass valve, and low limit valve to control the temperature. And it also controls economic cooling valves through the ELMS and ELEX system. Okay, so the pack control share in left and right cabin temperature control. Sometimes both packs are controlled differently. If the flight deck needs extra cooling, the left control cabin temperature control controls the left pack separately. Okay, if only the flight deck need extra cooling, and this time the cabin temperature controller controls the left pack separately. So the right cabin temperature controller continues controlling based on integrated mixed manifold temperature error. Okay. All right. So how control works? The cabin temperature controller compares actual position from the rotary variable differential transform feedbacks and the desired position calculated by the cabin temperature control. It then moves valves actuators to reach the correct position. Valve schedules depend on pack on-off status and the normal low backup operations and pre-positions when pack is off. All right. So why these controls are important? So cabin temperature control scheduling helps to reduce RAM air usage and prevent air cycle machine fan surge and keep compressor temperature within limits and maintain stable cabin comfort. And next one, Ramya door control priority order. So the protect air cycle machine from the surge if LLV and the TBV turbine bypass valve fails, and prevent compressor overheating and keep mixed manifold under 35 Fahrenheit, I mean 2 Celsius to prevent freezing. Okay, and control normal feedback, normal pack temperature, and rotary variable differential transformer send door position feedback to the cabin temperature control. The second stage turbine bypass valve TBV controls priority. So protects air cycle machine surge if RAM air dose fails, provide standby cooling for air cycle machines fails, support economy cooling mode flow controls, prevent max manifolds freezing, and control pack outlet temperature. RVDT provides valve position feedback to CTC. Summary, the cabin temperature controller is the main computer that controls the air conditioning pack. It uses IMMT as the target temperature for the mix manifold and adjust valves and ram air doors to control the pack temperature. It also ensures safety by preventing compressor overheating, air cycle machine surge, and freezing in the system. All right. Okay, this is a graph. You can see how it look like. Okay, this is called what we discussed before. Okay. All right, now let's go to the another one, control part 2, low limit valve control. So the cabin temperature control controls the low limit valve with the following priorities. Highest priority, keep condenser inlet temperature. Highest priority is keep the condenser temperature equal or more than 34 Fahrenheit, means 1 Celsius. This prevents water from freezing inside the condenser hot section. Low priority is control pack outlet temperature. Okay, control pack outlet temperature when the control pack outlet temperature when turbine bypass valve is fully open and mixed manifold temperature is lower than IMMTE reference or below 35 Fahrenheit. Okay, all right. Okay, economic cooling valve, ECV control. The cabin temperature controller does not directly power the valve. Instead, it sends the command to the electrical load management system. How it works: to open economy control valve, electrical load management system removes power from relay and air pressure opens the valve. And to close the economic cooling valve, electrical load management system energize relay 28 volt DC to solenoid, air pressure closes the valve. So the sensors, temperature plus rotary variable differential transformers, the cabin temperature controller monitors pack temperature sensors. Okay, cabin temperature cabin temperature controller monitors pack temperature sensors and valve position sensors, rotary variable differential transformers. So it uses this data, pack control, built-in test, and system identification. So standby cooling indications: when pack is in standby cooling mode, AIMS shows ICAS message like pack mode left or right, and the air synoptic standby cooling near the pack symbol. Okay. All right. Yeah, so the pack off position, cabin temperature control pre-positioning. When the pack is off, the cabin temperature control sets value position differently for airborne versus ground. So in flight, pack off, ram air inlet 98% closed. Okay, so the LLB also fully closed, TBV also partially open, like 0.15 percentage, and the ECV totally closed. On ground, in pack off, Ramya inlet fully open, and the LLV fully closed, and the TBV, these valves, okay, fully closed, and the ECV is closed. So CPC interface, backup protection. So air supply cabin pressure controller monitors compressor temperature, pack discharge temperature. We talked before, right? So important, air supply cabin pressure controller uses its own sensors, not the cabin temperature control. That's why I told you there's so many sensors, and some sensors used for the cabin temperature controller, some sensors used for the air supply cabin pressure controller. Okay, air supply cabin pressure control, they not use the sensors used for the cabin temperature control. So air supply cabin pressure controller will shut down the pack if compressor temperature is more than 490 Fahrenheit, means more than 254 Celsius for 5 seconds. Then the air supply cabin pressure controller will be shut down. And also the pack overheat more than 99 Celsius for 10 seconds if cabin temperature controller fails. It also provides backup flow control and also keeps temperature within safe limits. All right, for the summary, the cabin temperature controller controls pack temperature using valves like LLV, the ECV, and its monitors, sensors, and valve position. It prioritizes freeze protection, then temperature control. And the ELMS operates the ECV, and the ACPC, means the air supply cabin pressure controller, provides backup protection and can shut the pack down if temperature becomes too high. All right. Okay, you can go through this one also. All right. Stop the video and you can go through this one. All right, so now let's go to the we talk about the packs. Okay, so when the cabin temperature controller controls the left pack, when the cabin temperature controller controls the left pack, and the right cabin temperature controller controls the right pack. When the air cycle machine is working normally, the cabin temperature controls internal pack air temperatures, pack outlet air temperatures, and it does this by adjusting secondary stage turbine bypass valve. They will adjust the turbine bypass valve and the low limit valve and also ram air door actuator. These components work together in sequence to control the pack temperature. Okay, we discussed before. And now the target temperature control, IMMT, is a target temperature control. The cabin temperature control controls the pack to maintain the target called integrated mixed manifold temperature error reference. So the turbine bypass valve is in the main control valve, and the low limit valve and the ram air doors are used when the turbine bypass valve is fully open and more control is needed. This helps reduce unnecessary ram air usage. Okay, so the left and right packs coordination. The right cabin temperature controller is the main controller of mixed manifold temperature, and the left cabin temperature controller follows the right cabin temperature control. So this keeps both pack outlet temperatures within 10 Fahrenheit, means 5.5 Celsius of each other. So exception, if the right pack is off or overheated, then the left cabin temperature controller takes control. So different cooling needs, sometimes flight deck needs more cooling than cabin. In this case, the left cabin temperature controller may controls left pack separately, and the right cabin temperature controller continues controlling based off target temperature. Okay, so the economy cooling and the standby cooling. The economy cooling valve ECV is used for economy mode, improves airflow at the high altitude and low pressure, and the standby cooling bypass air cycle machine if it is fails. So the compressor outlet temperature controller, the compressor temperature controllers uses ram air system flow controls adjustments to keep compressor outlet temperature within limits, prevent overheating, and if needed reduce airflow or shut down the pack for protection. So the condenser inlet temperature control, the CTC uses low limit valve to prevent freezing, and minimum allowed temperature is 34 Celsius, 34 Fahrenheit, 1 Celsius. And if temperature gets too low, low limit valve adjusts the airflow. This prevents ice formation in the condenser section. So summary, the cabin temperature controller controls the air conditioning packs using valves like turbine bypass valve and the low limit valves, and ram air to maintain the target temperature. Okay, the right cabin temperature controls leads and the left follows to keep both packs balanced. It also protects the systems from overheating and freezing by adjusting the airflow and controlling temperature. All right, yeah, this is the same picture I showed before. You can go through it. All right, always used to mean the low limit valve and the secondary stage bypass valve. They do a big work in the packs in the Boeing 777. Okay, all right. Now the pack outlet temperature control. The cabin temperature controller controls the pack outlet temperature mainly using same bypass valve and the economy cooling valve and the ram air doors. The cabin temperature controller can adjust airflow to control the temperature and reduce pack output temperature or stop the pack if protection is needed. And the freeze protection, mixed manifold. In the mixed manifold, freeze protection is to prevent ice formation in the mixed manifold. Cabin temperature controller keeps outlet temperature above 2 Celsius minimum. If the temperature drops below that, the cabin temperature controller increases pack outlet temperature to prevent this freezing. Economy cooling mode, the cabin temperature controller select economy cooling mode when these conditions are met. The air cycle machine is operating normally. Condenser inlet temperature sensors are working. The economy control valve is available, and the pack flow is low or outside air is cold below -Celsius or 20 Fahrenheit. Condenser bypass conditions are satisfied. These conditions change depend on an altitude. Okay, so what happens in economy cooling mode? Airflow path changes. Air goes from secondary heat exchanger and directly to the turbine 2. In this mode, air goes from secondary heat exchanger to directly to the turbine 2 in the air cycle mode machine. Economy cooling mode. Okay, so the turbine bypass valve controls pack outlet temperature, and the low level valve LLV keeps condenser inlet more than 1 Celsius, low limit valve. Okay, so the system uses less energy and improves efficiency. Exit from economy cooling valve. This pack leaves economy cooling mode if any of these occurs. What? Condenser bypass conditions are no longer valid, and turbine bypass valve is fully closed and ram air is more than 80% open, and outlet temperature is more than target temperature by 5 degree Fahrenheit or 2.7 Celsius. Pack flow schedule is 4 is active, and actual pack flow is too low or high out of limits. Okay, so important notice, there is no flight deck effects when operating in economy cooling mode. Okay, there is no flight deck effects when operating in economy cooling mode. Okay, passenger comforts remains normal. So the summary, the cabin temperature controller controls pack outlet temperature using turbine bypass valve, cooling valves, and ram air. It keeps temperature above 35 Fahrenheit, it means 2 Celsius, to prevent freezing in economy cooling mode, and air bypass part of the air cycle machines to improve efficiency, while turbine bypass valve and low limit valves maintain safe temperature limits. Okay. In addition to compressor or pack outlet overheat, the pack can enter operations in addition to compression pack outlet overheat, the pack can enter non-normal operations due to failures such as air cycle machine failure, pack temperature sensor failure, economy cooling valve failure, low limit valve failure, turbine bypass valve failure, ram air door failure, single pack operation failure conditions. So the standby cooling mode, the pack goes into standby cooling mode when certain faults occurs. Main causes are air cycle machine failure, both condenser inlet temperature sensor fail, and ECV fails in the open position. So how to standby cooling works? There are two ways the pack can operate the standby mode. Okay, the first one is heat exchanger cooling, and this one is condenser bypass. In the heat exchanger cooling happens when the air cycle machine fails, pack continuous cooling using heat exchangers only. And the condenser bypass happens when both condenser sensors fail or ECV is stuck open. So indications to the crew when the standby cooling is active, ICAS message called pack mode L. or R. And the air synoptic display like standby cooling shown near the pack. Okay, these are the indications of the crew. The air cycle machine failure, heat exchanger standby mode. If the air cycle machine fails, the pack may still operate or stand by cooling if condenser bypass conditions are valid or the other pack cannot provide enough airflow scheduled for demand. If not, the pack will shut down. The pack can restart later if conditions become normal again. So valve position in the standby cooling ACM failure mode. In this mode, the cabin temperature controller sets economy cooling valve to fully open and the low limit valve to fully open and the turbine bypass valve also fully open. So temperature control in this mode, ram air doors are used to control pack outlet temperature. Okay, ram air doors are used to control pack outlet temperature and the cooling is mainly through heat exchangers only operation. Okay, so cooling done only from the heat exchangers. So extra protections, if pack outlet temperature is still 5 Fahrenheit above the target temperature and turbine bypass valve is not fully open, then the cabin temperature controller sends signal to the ASCPC, and the ASCPC reduce pre-cooler outlet temperature to 250 Fahrenheit for additional cooling protection. Okay, so summary, in non-normal conditions, the air conditioning pack can enter standby cooling mode due to failures like air cycle machines or sensor fails. And in this mode, the system uses backup cooling method, heat exchangers or bypass valves. And the CTC controls valves and the ram air doors or maintain safe temperature. So if needed, the ACPC provides extra protection. Okay, you can see this graph. Okay, you can see this is the low limit valve. This is the second stage turbine bypass valve. This is the economy cooling valve. Okay, these three are very important valves in the air conditioning system in 777. Okay, so this is the mixed manifold. Okay, all right. Okay, now let's go to the pack cooling and mixed manifold temperature failures. All right, so in the first one, condenser sensor ECV failure, the condenser bypass standing cooling mode. If any of these happen, both condenser inlet temperature sensor fail or economy cooling valve fails open, then the pack may enter standby cooling mode, but only if the condenser bypass conditions are valid. If not valid, pack shutdowns. So in condenser bypass standby mode, the seat cabin temperature controller controls pack temperature using economy cooling valve to fully open, low limit valve to fully close, and the turbine bypass valve to modulating, like adjusting, and the ram air doors modulating. Okay, let's go to the second one, pack sensor failures. Affected sensors, pack inlet temperature, pack inlet differential pressure sensors, flow sensors, and the compressor inlet temperature sensors 1 and 2, and the condenser inlet temperature sensor 1 and 2. If sensors fail, the pack inlet pressure flow failure, CTC uses a CPC as a backup. If both sources fail, then the pack stops. The compressor outlet temperature failure, backup source sensor 1, 2 plus ASCPC. If all fail, pack stops. Condenser inlet temperature fails. If both sensors fail, pack may go to standby cooling mode or may stop depending on the conditions. And the ram air door failure, if the ram air doors fail, cabin temperature controller reduce pack flow and minimum flow is scheduled to 4 and other pack increases flow to maintain total cabin ventilation. If RVDT fails, the CTC driven ram air doors to fully open. Then the identified as actuator fail. The low limit valve failure, if the low limit valve fails, CTC adjust pack flow. Okay, if low limit valve is failed, what happened? Cabin temperature controller adjusts pack flow. Keeps condenser inlet as a more than 1 Celsius. Turbine bypass valve fails. If turbine bypass valve fails, what happens? Cabin temperature controller uses ram air door to control the temperature. If temperature still cannot be controlled, cabin temperature controller adjusts pack flow, maintain mixed manifold temperature control. If rotary variable differential transform fails, LLV or in the turbine bypass valve, so cabin temperature moves valves to 60% open. Okay, because then don't have any feedback. Uses timing to open, position it, then mark it as a valve failure. So as a summary, if sensors or valves fail, the cabin temperature controller switch to backup control or standby cooling mode. It uses remaining working components like rammer doors, turbine bypass valve, and the low limit valve, and flow control to maintain safe temperature. If critical sensors fail completely, the pack will shut down for safety. Or as a single pack operations, in the single pack operations, only one air conditioning pack is working. So the cabin temperature control must do more work to maintain cabin temperature and the airflow. So the normal control, even in the single pack operations, cabin temperature controller still controls turbine bypass valve, low limit valve, and the economic cooling valve, and the ram doors. These are used to keep the mixed manifold temperature at the target reference temperature. So the cabin temperature control also tries to keep airflow similar to when both packs are operating. If pack cannot meet demand, if the pack cannot maintain the required airflow or the temperature more than 2.7 Celsius above IMMTE, then the cabin temperature control uses extra methods like economic cooling mode. Is selected if conditions allow, improves airflow efficiency, and lower pre-cool outlet temperature via ASCPC. The CTC requests ASCPC to reduce pre-cool outlet temperature, and target is 121 Celsius. Only works if the turbine bypass valve is not fully open. If turbine bypass valve adjustment, the turbine bypass valve is used to control airflow temperature. If the turbine bypass valve is not fully open, it helps increases cooling performance and increases pneumatic pressure. If turbine bypass valve is fully open or pre-cooler temperature reduction is not available, example wing anti-ice on, then the cabin temperature controller commands ASCPC to increase pneumatic pressure about plus 6 psi based on high pressure shut-off valve control. So control priority, first priority for the pack flow, then temperature control, but overheat protections always has higher priority. Lower recirculation fan control, in some cases, lower recirculation fan may stop conditions aircraft on ground, pack at maximum cooling, mixed manifold temperature 12 Fahrenheit above IMMTE. Why fan stops? Reduce circulated warm air helps the pack reach required IMMTE temperature faster. Alright, the summary: in the single pack operations, one pack must handle all cooling. The cabin temperature controller uses TBV, LLV, ECV, RAM air, and even system pressure changes to maintain temperature and airflow if needed. It reduces circulations, airflow, or asks ACPC to increase system pressure to maintain cabin comfort. Alright, so that is the end of a long lesson. I think you got the idea about the things inside the packs, okay, especially the valves, right? The low limit valve, and the turbine valve and the economic cooling valve. These do the major thing inside the packs. Packs, okay, this is the way how the aircraft they cool inside the cabin. All right, so we have more lessons regarding this chapter. 8821 is very big chapter, very important chapter. So I will do one by one. And if you still not subscribe K-Vision Engineering, please subscribe and please share these videos with your friends. And all right, and if you have any questions, please ask me. I will try to give you my answer, and if I don't know, I will ask from my senior guy. All right, okay, that's all. Thank you very much for watching this video and also following this channel. All right, see you on another lesson.